Welcome to Chintu Mintu classes. Today, me and Satvik are gonna explain you K-Nearest Neighbor. So the discussion flow will begin with introduction, then we will tell you what is KNN, then the theory part, then the implementation part, and then we will end with some exercises. In this machine learning tutorial, we will look into what is K-Nearest Neighbor classification. We will go over some theory, then we will write Python code, we will build a model, and then you will have an exercise to work on. This, you are doing a classification for Aries flowers. So starting with a simple one, what is KNN? K-nearest neighbor is a simple algorithm that stores all the available classes and classifies the new data or case based on a similarity measure. It is mostly used to classify a data point based on how its neighbors are classified. Let's take below one example. Two chemical components called rutine and myrcene consider a measurement of rutine versus myrcene level with two data points, red and white wines. They have tested and were then fall on that graph based on how much rutine and how much myrcene chemical content present in the wines. Now here I have a picture of vesicle flower, which is one of the three types, and based on a sepal width and height, you can actually figure out which of the three flower category it is in. So we are classifying an Irish flower into one of the three classes, Setosa, Versicolor, and Virginica, based on sample width and height. You can plot sepal width and height in that kind of 2D scatter plot, and you can plot all your data points. You know all the data points for which you know what is the class. Now let's say you have built a model and you have a new data point. So yellow data point, you don't know what class this is. And using KNN, you want to figure out. By looking at the graph itself, you immediately get an intuition that this has to be blue color, which is Virginica, because it is more near to this cluster. And KNN works just like that. In KNN, you first figure out what is the value of my k, and you can figure out the value of k by trial and error. They just know like specific rule to it. Usually people use 5, but you know you can change it. So let's say here I use k is equal to 3, and this means I need to figure out the most nearby 3 data points. So the most nearby 3 data point using Euclidean distance, which is just a simple distance between these 2 points, are these 3. And since these 3 are Virginica, my yellow data point is also Virginica. K-nearest algorithm near K nearest neighbor algorithm is super simple. You figure out the most nearby k data point, and whichever data point category that data point belong, my new data point belongs to that category. Let's say my k is 10. Again, you figure out the most nearby 10 data points. So I have 7 Virginica, 2 versicolor. You take the highest number, which is 7, which is Virginica. How about if k is 20? Well, then you have a problem because your total number of data points in Virginia class are very less. So now it is misclassifying this yellow data point, saying that this is versicolor, because the rule is you figure out the most nearby k data point and you take the maximum count. So here k is 20. So maximum data points which are near the versicolor, which is 11 data points. See, 11, 7, 2. 11 maximum number. But this will be wrong because clearly by looking at the graph, you know that this yellow data point is actually Virginica. So you have to carefully choose a value of k such that it is not very high or not very low. Again, style and error depends on your situation. It depends on your training data set and so on. Let's write Python code now. One thing I would like to clarify is that here we had only two feature sample, width and sample height, but KNN works equally if there are more than two features. You know, there could be n number of features and KNN will just work fine. I mean, as human, we can't visualize it but sorry, but mathematically it should just work okay. Now we are going to use same Irish data flower data set for our coding.
Now we will implement the coding part, the K-nearest neighbor using the scikit-learn library. So the K-nearest algorithm is a type of supervised machine learning algorithm. KNN is extremely easy to implement in its most basic form and yet performs quite complex classification tasks. It is a non-parametric learning algorithm, which means that it does not assume anything about the underlying data. This is an extremely useful feature since most of the real-world data doesn't really follow any theoretical assumption, for example, linear scalability or uniform distribution. Let's start implementing the KNN algorithm using scikit-learn. Now we are going uh, to use the famous Irish data set for this example. Okay, so here I have imported NumPy as NP and matplot.pyplot as PLT and pandas as PD, and this is the example reference photo of the iris flower dataset, and you can see petal and sepals are two different things, and this will be further used for the prediction of the iris flowers. Okay, so you can copy this URL from the description. This is basically the dataset for our this project, and so now I am going to check the features name of this dataset. Wait, something out. Oh, yeah, here feature. So here we have sepal length, sepal width, petal length, and petal width as our features of this dataset. And now we will get the target names. So we have array setosa, versicolor, and virginica. So now we will create a data frame. So here we have the table, a data frame table. So this column will show that sepal length in centimeter and sepal width in centimeter. So 0 indicates setosa, 1 indicates versicolor, and 2 indicates virginica, like that. And now we will implement this code. So here what we have done is like we have added a column target. Okay, here you can see now set target is 1. So, so we can see that 50 index it is virginica, it's versicolor flowers, and if we set target to 2, then we will get it for virginica flowers. It will start from 100. Okay, so basically I have 150 training samples, out of which first 50 are Setosa, 50 to 100 will be versicolor, and 100 to 150 is Virginica. So when I do nothing colon 50, df0 will be will have all Setosa flower, and If we do 50 colon 100, df1 will have vertical all vertical powers, and if I do 100 colon nothing, df2 will have all virginica power. And now I'm going to use matplotlib for the subplotting work. So after running the code, you can see we have got the matplotlib graph for this, and this is the sepal and this is sepal width. So I have executed the petal length for the petal with the matplotlib graph. So for all this code, you can go to visit our GitHub link that we will be going to provide in the description. And now we will perform the train test split for this dataset. So after running the train test split, we got the x train as 120 and x test as 30. So which means that we are going to have 30 test cases. Now, as you all know, Google is our best friend. So here comes the exciting part. Now we are going to perform the K-nearest neighbor classifier. So in Google, search for sklearn KNN classifier. So from here, what I will do is to perform my most favorite task, that is Control C and Control V, copy paste. So from here I will copy this and paste it in my Jupyter notebook. And now I will write. I will also copy this line and change this name to KNN and shift enter. Now for the plot, for the prediction, KNN dot fit. So k neighbors classifier n underscore neighbors is equal to 3, and knn dot score x underscore test comma y underscore test. It is 1. So as you can see, our model is so accurate that it is giving 1. So like 3 is the ideal number for this model. So now we can change it, we will change it to 10 for some deviation. So after that, you can see there is slight our prediction is very close. So now we will plot the confusion matrix. So from sklearn sklearn dot matrix, we will import the confusion matrix, and y underscore spread will be knn dot predict x underscore test cm is equal to confusion underscore matrix y underscore test comma y underscore spread. So as you can see, we have it has given us the confusion matrix for this 11 12 6. This diagonal shows the only the correct prediction, only the truth part of the prediction. So we will, for the pattern understanding visualization, we will use Seaborn, and I have written the code for it. It will, the x label will be predicted and the y label will be shown for truth. So shift enter. So as here you can see, anything on the diagonal are your correct prediction. This means this 0 is set as and this 0 is set as, and this is the truth prediction. This is saying is 11 times it was Setosa and my model predicted it to be Setosa. So this diagonal is all correct prediction. Anything that is on not on this diagonal is wrong prediction. So one time what happened, the truth was vertical that is this, and it is said it is Virginica. You see, 2 means Virginica, 1 means versicolor. So out of 30, only one time I got the prediction wrong. Remaining 29 times it got right, and hence the score is so high. So now you can also use classification report for precision, and this is the code for it. From scikit-learn.matrix import, you have to import the classification report, and you have to print classification report y underscore test comma y underscore pred, and yeah, you will get this. Precision is for 0, which is क्या था 0 0 satosa है ना. हाँ. And you, by running this code you will get this table. So for 0 which is satosa, precision is 1, and for 1 which is versicolor, for that is 1, and for 2 is that is virginica, it's 0.86.
So that's all pretty much that I had for this video. KNN again is a very simple classifier, very easy to understand. If I explain it to high school students, they will also understand it very easily. Now the code you saw was so simple, 3 lines. It's like freaking simple classifier. So if you go to my GitHub page, I'm gonna provide all these links in the description below. Exercise.md has this exercise, and this exercise is the most important part of my tutorials because learning coding or machine learning is like learning swimming. Until you practice, you're not going to get much benefit. So practice is extremely important. I want you to load digits dataset from scikit-learn and use K-Nearest classifier to classify digits from 0 to 9. Now you also need to plot confusion metric classification report like how we did it in the current video. Also for our main classifier, you need to find an optimal value of k that gives you the maximum score either by trial and error, manually trying it out, or by using research CV. Now a good student would try on their own and then only they will click on the solution link. Now coming to the bad student, he would directly click on solution link and try to look at the solution. But the downside is that they will get a virus which I have embedded encrypted into this GitHub, and your computer will start sneezing and your computer will have a fever. So if you don't want your computer to have a fever, please try the solution on your own and then only click on solution. Now, as we conclude, let's remember that KNN serve as a foundational building block in the vast landscape of machine learning algorithms. By understanding its principles, we empower ourselves to harness its potential effectively. I encourage you to continue exploring KNN and its variations, experiment with different datasets. So let's end this video and thank you very much for watching.